Hello friends, this is Professor Ronika Yusuf and today we will talk about sample design in research. Sample design refers to a complete plan that a researcher prepares in advance for selecting a sample from the population. It specifies how a sample will be chosen, what unit will be included and how many items will form the final sample. Sample design is a definite pre-planned procedure used to obtain a sample from a given population. It outlines the method of selecting sample items, the size of sample, and the steps that will be followed during sampling. It is always determined before data collection begins, and the chosen design must be reliable, representative, and suitable for the research objectives. So, why sample design is important? A clear sample design ensures that the researcher collects accurate and meaningful data. The sample truly reflects the population, errors and biases are minimized, time, cost, and efforts are used efficiently. Good sample design is essential for ensuring the validity and research conclusions. So what are the steps that are involved in sample design? A researcher must follow several important steps while preparing a sample design. Each step ensures that the sample selected is scientific, representative, and appropriate for analysis. Now, step first is type of universe. The researcher must first understand the nature of universe being studied. A universe can be finite when the number of items is known. For example, 1,000 students or 10,000 students. Infinite when the exact number of items is unknown, or very large, for example, stars in the sky, numbers of insects in a forest. A clear understanding of the universe helps in choosing the right sampling approach. Second step is determining the sampling unit. A sampling unit is the basic unit that will be selected for the sample. It may be a geographical unit such as a village, district, or state. A construction unit such as a house, shop, or flat. A social unit such as a school, club, or family. An individual person. The researcher must decide at this stage what exactly will be sampled. Step third is preparing the source list. The source list, also known as the sampling frame, is a complete and accurate list of all units in the population from which the sample will be drawn. A good sampling frame must be comprehensive, correct, updated, representative of the entire population. A defective or incomplete sampling frame increases the chance of bias. Fourth step is decoding the sample size. The sample size refers to the number of units that will be selected from the population. An ideal sample size is one that is not too large so that we can avoid the unnecessary cost, not too small to avoid inaccurate results, large enough to provide reliability, validity, and representation. The sample must be optimum, meaning it balances accuracy with cost and feasibility. Now, what are the factors affecting sample size? While decoding the sample size, the researcher must consider objective of the study, variability in the population, acceptability margins of error, budget and resources, time availability, desired confidence level. So all of these factors help determine the most efficient sample size. Step fifth is choosing the sampling procedure. The final step is to choose how the items will be selected. The researcher must decide whether the sample will be based on probability or non-probability. Which selection technique is best suit the research question. How to implement the technique practically. This step ensures the sample is chosen in a systematic and unbiased manner. Now, the criteria for selecting a sample design. While choosing the sample design, the researcher must remember that sampling involves two types of cost. The cost of collecting data, the cost of incorrect conclusions. Although data collection costs can be reduced with proper planning, the real challenge is avoiding the cost of incorrect inference. Incorrect result can arise from systematic bias or sampling errors. So, what a systematic bias is? Systematic bias occurs when the sampling procedures consistently produce results that differ from the true population characteristic. It can't be removed by increasing the sample size. It can only be eliminated by correcting the cause of the bias. So what are the causes of systematic bias? Systematic bias may occur due to inappropriate sampling frame, defective measuring devices, non-responsive issues, natural bias in reporting, indeterminacy principle. Each of these must be carefully handled to ensure accuracy. Cause 1. Inappropriate sampling frame. If a sampling frame does not correctly represent the population, then the sample selected from it will automatically be biased. For example, using a voter list to study child health, the sampling frame does not match the population of interest. Cause 2. Defective measuring device. Systematic bias can arise when the questionnaire is poorly designed, the interviewer is biased, physical measuring instruments are inaccurate. Any defect in the tool used to gather data will produce faulty results. Cause 3 is non-response. If some people included in the sample do not respond, the final sample may not represent the population. Non-response often occurs because people refuse to participate. They cannot be contacted. They do not return questionnaires. If non-respondents differ significantly from respondents, biases occur. Cause 4 is natural reporting bias. People sometimes intentionally underreport or overreport information. For example, individuals understate income in tech survey and individuals overstate income when asked for social status survey. Such natural biases distort the results. Fifth is indeterminacy principle. People often change their behavior when they know they are being observed. This leads to results that do not reflect their natural real-life behavior. This phenomenon introduces systematic bias in studies involving observations. Now, what are sampling errors? Sampling error occurs because only a part of the population is studied instead of the entire population. Unlike systematic bias, sampling error can be reduced by increasing the sample size, improving the sample design, ensuring randomness in selection. Sampling error is natural, but it must be minimized. So to conclude, the sample design is the backbone of any research project. A well-planned sample design ensures that the researcher selects the right units, uses the correct techniques, and collects accurate data. By following proper steps and controlling systematic bias and sampling errors, the study becomes reliable, valid, and scientifically sound. Thank you very much for watching this video.